All right, guys. Thank you for joining me today. What we're going to discuss today in section 1.8 is an introduction to equations. That should be a word that you're pretty familiar with. In 1.1, we talked about equations versus expressions, with the main difference between the two. I'll circle one here. All the equations, again, have an equal sign. Okay, so I try to circle that so that it stands out for you. Every time you hear the word equation, there's going to be an equal sign in the problem, and you're going to see a variable in many of the problems as well as we move on throughout algebra. To get started, we're going to talk about true, false, and open equations. Okay, these aren't very tricky. These should be pretty straightforward. If you're thinking true, and false, true is just something that makes a true statement once it is solved. So if I'm looking over here at this first one, 12 plus 5 equals 10 plus 7. So all you have to do is simplify both sides of the equation, and I end up getting 17 equals 17 when I solve both of those, because 12 plus 5 is 17, and 10 plus 7 is 17 as well. That makes a true equation, so nothing tricky there. If you simplify it and you get one number on one side equals the same number on the other, it's a true equation. Now as we take a look here at false equation, you can probably guess what that's going to mean. A false equation, when you simplify, will not create a false statement. Because I don't have a ton of room up here and writing with my finger, I'm not the greatest at it, I'm going to do it down below. I have 7 times 5 in this one right here, which is 35. And in this equation it says that equals 55. Well, I'm looking, 35 does not equal 55, so that is a false equation there. Okay, now moving on to this one over here on the right, open equation. All right, well, what makes this one open? We'll take a second to look at this and figure out, well, what does this have that the other two equations that we just looked at does not have? And if you've been observant enough to find it, it is this variable right here, okay, that x. We call this an open equation because we can't classify it as true or false, which kind of go under closed equations. We can classify those as true or false. This one we're not sure of because we don't know what x is, okay? If I told you that x equaled 2, if I say x equals 2, okay, then we could maybe plug in and solve for that. All right, we could do 8 times 2 plus 4 and find out if that equaled 20. Okay, well, 8 times 2 is 16 plus 4 equals 20, and 16 plus 4 is 20, and 20 does equal 20, okay? But we didn't know that x equaled 2. I just picked that number out. And there was nowhere up here when I look at this equation that tells me x is this number. So I could think to myself, well, what if x was 5? What if x equaled 5? Well, 8 times 5 plus 4 equals 20. Let's find out if that's true. 8 times 5 is 40. 40 plus 4 equals 20. And as you see, 44 is 40 plus 4 does not equal 20. Okay, that one is not true. So when I look at these two things, I notice, well, if x was 5, it would be false. If x was 2, it would be true. We cannot classify this, and since we are not told what x equals, we just call this an open equation because we can't determine that. Okay? So down below is a true, false, and open equation. If you want to take a second, pause the video, and make your own, that would be a wonderful idea, just to give yourself an example and kind of be creative in creating a true, a false, and an open equation. We're going to move on and take a look at what does it mean to find, whoops, I'm going to erase that there. I was not trying to do that. Let's get that erased there. Oh, that's even more. Let's go back. Here we go. Okay, so we are going to investigate what it means to solve an equation. So it says, what does it mean to solve an equation? To solve an equation means to find the value of the variable. I'm going to hop down here. Find the value of the variable that makes, ooh, it's a terrible E, that makes the equation true. Okay, as soon as I can find out, well, does B equal this? Is this a solution? Okay, if that number, okay, when plugged into the equation makes it a true statement, then we have found the solution. Okay, So let's take a look at this first example. It says, is b equals 6 a solution to the following equation? So we take a look at this first one here first. Okay, 2b plus 12 equals 32. And in order for this to actually be a solution, because it's a yes or no question, we need to make sure that it comes up with a true equation, which is what we just talked about on the last slide. So we'll plug this in. B equals 6. We notice 2 and b are next to each other. Okay, and that means they're multiplying. So we're going to have 2 times now 6 plus 12 equals 32. 2 times 6 is 12. So now we have 12 plus 12 equals 32. And when I add 12 and 12 together, I should get 24 equals 32. And that is my final answer there. So when it asks us, is 6 a solution for B? The answer is no, because we do not get a true statement. So the answer to this one would be no, it is not. Okay? Let's take a look over here to the right. This says 4b minus 3 equals 21. So we're going to plug in 6 again for b, and since 4 and b are next to each other, we know they're multiplying. We're going to have 4 times 6 minus 3 equals 21. Okay? Well, 4 times 6, order of operations says I have to do that first. 4 times 6 is 24. 24 minus 3 equals 21. My last step would be to subtract 21 equals 21. That is a true statement, so we would say yes, b equals 6 is a solution. Okay, I apologize for the mess there, but I hope you took away from that. If we get a true statement, then that number we plugged in is a solution. If we get a false statement, the number we plugged in is not a solution. Okay, and we're going to move on. So this next slide here says, well, now can we take a real-life word problem and set up an equation, an open equation, so that we could solve it? Okay, so as we look at this first one, it says, Shane is working to buy a new iPhone 6 Plus. He works at the Cougar Cafe making $14 per hour. If he needs $434 to buy the iPhone, how many hours will he need to work? It says create an equation that can be used to solve the problem. So the one unknown is the hours. That's why I underline that. So it's a good idea to underline the things or make those things stand out that you think are important. So how many hours does he need to work? So we know we need a variable because all open equations have a variable, right? We talked about that on the first slide, have a variable. And our variable needs to represent V-A-R-I-A-B-L-E, sorry. It needs to represent our hours. So a lot of times you'll see X or something used. Make it make sense to you. So how about for hours? We have that as H, okay? And we know that he makes $14 per hour. So every single hour he works, he's going to make $14 more. Well, instead of adding 14 every time, a shortcut could be 14H, because when those are next to each other, we know that there's a multiplication sign in between, whether you put it there or not. 14 times H equals, and now we need this to equal our goal, okay? Well, what is our goal in this problem? Our goal is to buy the iPhone Plus for Shane, and his goal, how much he needs, is $434. So his hours times how much he makes per hour needs to equal the amount of money that he would like to make, $434, okay? You can then use that equation, and we'll find out in Chapter 2, well, how do I take something like this and quickly find out how many hours he must work? Because it's one way to do it, and you might be thinking is guess and check. Well, what if he works 10 hours? I can plug in 14 times 10 equals 434, and let's find out, well, 14 times 10 is 140. Okay, then we're short, so we know we have to up this number here, right? So that's guess and check. We're going to find out at the next lesson in 2.1 how we quickly solve this in one step. Okay, so look forward to that. Last thing here, just a little something I snuck in. It says, all you athletes out there, just kind of a random question that something will be useful to see in the chapters to come. What is an ordered pair, and how do we write an ordered pair? So an ordered pair means two, right? There's a pair of them, two. So it is two numbers. They are ordered, right? And we use X and Y as the two variables, and we order them. You may have seen this in the past. We just do X, comma, Y. Okay, that is an ordered pair. Something I think would be a great idea to jot down in your notes. If you don't, it's not the end of the world. But this will be something you'll see as we move on, as we try to find more solutions, which we did on the previous, 2 slides ago. Knowing where X and Y goes in the ordered pair will be very helpful in that. and also as we move into graphing. Okay, that's all for 1.8. Kind of a short lesson here today. I hope you guys learned some. Look forward to seeing you guys in the next video. Adios.